Welcome to number 9 of the series on the Orange Pi 5 Plus. I found a way to talk about the commands we've learned so far, but let me go back to our little primes program and show you what's going on. As you can see here in project 001, where I have assigned you the task of writing or benchmarking the generation of prime numbers up to the 64 minus 1. And here I've got a large number of files, and if I do a PS, we can see that I'm just running the simple screen recorder, but I have running from another window the primes. So if I do a PS A to look at all the tasks or programs that I'm running as atoms, you'll see that I've got down at the bottom 4 copies of primes running. They've been running almost 6 minutes, and I'm up, going up to all the primes less than 24 billion. And the script, if I cat run.shell, the script is going to run up to all the primes less than 36 billion. This is, let me just VI this thing, run.shell, and look at the front. Here I compiled primes, and then all statements or execution lines that start with the pound sign. Not the pound like British pound, but the American weight pounds. These are comments, and I commented those out because I've already run those up to file 20 out. And now I've started the ones that the 4 that you saw that are running up to 24 billion. And the script waits until all 4 have finished. If the first 3 finish and number 4 is running, we do not go to the next 4 executions of primes until that one finishes, whatever time it takes. Hopefully these are pretty close together. Now, I also mentioned something about gaps. And if you go to, let me move this over because I want to do something. If you go to the web and do a search on prime gaps, you'll come up with one of the first links is to Wikipedia, and they have a article on prime gap, and it's showing you how the number, what is this? This is the number, the prime gap frequency distribution. So the small gaps like 2, 4, 6, 8, etc., those occur quite frequently, but as you go higher and higher, the large gaps, the large distances between successive prime numbers decreases. And there's a table here that shows all the results up to the largest prime less than 2 to the 64 minus 1. So somebody's already done this, which is fine. I just want to benchmark the Orange Pi 5 Plus. Just prove that we can do it. Also, you'll note in the news that people are finding previous scientific papers that were published were in error. And what you can do with your little Orange Pi 5 Plus is go back and recreate some old works, and that's exactly what we're going to do. Going back, I wrote a program. Let me clear this, and let me VI gaps. Very, very short program. What it does is it goes and from standard in, it reads the first prime number that I've got from a file, okay? Then it reads another number in and calls it current. This is the one I'm currently looking at. So I do a difference between the number that I currently have, which is going to be larger than the previous. Do this and we will check to see what this gap is. I start with gap equal to 0. So the first time we're going to get 2 and 3. So 3 minus 2 is 1, and 1 is greater than 0. So it's going to go down here and say, I have to recalculate gap or I generate a new value for gap, which is current minus previous, and I print that value out. And I also print the value of gap, and I give it 5 places, and then I'm going to print out the previous value, which is the one that has the lower value, so that the previous plus gap will give me the current value, and then reset previous to what is current because I'm now starting a new gap. Go back here, read another number, and I do this until scanf returns a value not equal to 1. What scanf does, it returns an int value, and if the value of scanf, the value it returns is a number of values that it has read in. In this case, we're trying to read in 1. If it doesn't read in 1, then it's going to be, if it reads in more than 1, I've got a serious problem. But if this value is not 1, then I want to quit. And so it'll quit, and I'm done. So that's my program. Going back again, we've got a large number of files that start from 0 to 1 billion, 1 billion to 2 billion, and 2 dot out. So these are the number of prime numbers in each one of those intervals. I'm going to look at all of them. So what I'm going to do is I'm going to cat start out, which means take 001 dot out through 029 dot out, and file by file output the first one, followed by the second one, all the way up to number 29, and pass those two as one stream to whatever program I want on the other side of the pipe symbol, which is a vertical bar, which is on the right-hand side of the keyboard just below the delete key on an Apple keyboard. I've compiled gaps. Well, that's the VI my makefile, and let's just do this. I have 2 programs that I can create with a makefile. One of them is the primes, which I showed you. The second program I can generate is gaps, and it's dependent upon gaps.c. I just do a compile. I do a thing where I strip the symbol table and some other stuff, and we will look at what that command does. And then I move gaps, the program that I created, into my bin directory so that I can execute it. So starting over, cat start out says take all the output files, put them all together as one, and it doesn't take disk space, and feed that to the gaps program. Now the gaps program is going to start with 2 and start doing the little calculations. And here you can see that the difference at 1, there's a gap of 1 starting at 2, there's a gap of 2 at 3, there's a gap of 4 at 7, and if you compare this to the left-hand side, you can see that we were up to 282. There's 282. I got an error from a warning from the screen recorder right in the middle here, so we're up to 282, which gives 436, 273, 009. Let's see what's going on here. There's 288, which is also, which is correct here. The gap is 288, starting at 1294268,491, which is what I get right there. Then we get 292. You notice that the output is slowing down because there are a lot more prime numbers I have to search to find the next largest gap. So that gets to 320, and you can see that I've matched all the numbers up to this point, so the program's working pretty good. So I'm going to stop it. So you write a program that does the same thing in your language of choice. Now, let's do the following. We are going to look at all the commands that we know so far. And I was going to have to do a lot of work to produce slides, etc., but I don't have to do that. I can go to man.cat-v.org/Unix, and I'll just pick the 6th edition, and I'll look at all the commands that are in volume 1. So someone on the web has gone and taken the Unix manuals for the 6th, well, actually they started with the 1st edition, 6th edition, 10th, 7th, and 8th. I just picked the 6th to start with. Let me enlarge this by doing a shift with the mouse wheel. Let's see, I've got this. Let me move it over here so that things don't mess up and I can demonstrate these. So let's go through these in alphabetical order. What's the first one that we know about? There's the cat command I was just talking about. So we go look at cat, and this outputs in teletype font, or yes, I think it's called Courier fixed spacing, catenate, and print. Well, it does more than that. So synopsis says cat file followed by other file names. Cat reads each file in sequence and writes it on the standard output. In C, that you are without any extra work because you did an include on standard io.h. You've got standard in, standard out, and you've got standard error, or stderr, which is the output stream or output terminal for error messages. And because we're not doing anything special with that, it comes out with our standard out on the screen. So both standard out and standard error come to your terminal window. So here, cat file prints the file. That is, if I do a cat makefile, then it outputs the contents of the makefile to the screen. And there you see the rule definitions for creating primes and gaps. Now if I do a cat number files and then I redirect if you've been reading your shell programming or shell book, you can take the contents of the output from a command and redirect it to a file, in this case file 3, and this says take the contents of file 1 plus the contents of file 2 and write it into file 3. So it concatenates the first 2 files and places the result in the third. So here's a typo. Okay, does it in? And there's also two other commands that are related, but we're not. Diagnostics, none. If a file cannot be found, it is ignored. And there's a bug. Actually, it's a user error because I don't know why you would do this. Well, I do know what you're thinking, but it can't happen. So you cat X and Y together, and you redirect that back into one of this files. And if you think about it, this gets to be recursive, because if you start with X and add Y, put it into X, now X is X plus Y, and you're gonna cat it, and this just causes strange results. What's the next one we know? Change directory. Well, the name of that command is changed to CD. And change directory says whatever directory name you give, directory becomes the new working directory. The process must have execute permission in the directory. To move into a directory, you have to have the permission bit for however you are associated with the directory. If you're the owner, then you have to have execute permission. If you're a group and you have group access to the directory, you have to have execute the X bit on. Because a new process is created to execute each command, change directory would be ineffective, so it's just interpreted and executed as a function of the shell. Chmod, or change mode. Most people just pronounce the commands by the way they're written. And there's a historical way of doing it, and then new people may mispronounce it, which is okay. We know what you're talking about. Change mode changes the bits. I did one where I did a plus X on the shell script. Now, the number which describes what the mode is going to become is determined by octal values. This is historical because the PDP-7 and the PDP-11 series from Digital Equipment Corporation were based on a 3-bit combination, which gives you 0 to 7, so it's octal, and so that's the reason for this. We'll come back to it. We can look at what the permission bits are for. Let's do ls minus l. Okay, they don't show you. This is an old. Well, it's the 6th version of Unix. They don't show you all the flags for the command, but we're going to do ls minus l on run.sh. First of all, it shows that I am the owner and it belongs to group Adams. Okay, 1667 bytes long, last modified August the 4th. Let me mention something about timestamps. For every file and for every directory, there are 3 timestamps. The date it was created, the date it was last modified, and the date it was last accessed. The ls command shows you the date and time for the last modification. The permission bits. The first bit is the directory bit, and this is just a file, so it's not a directory, and I gave it read, write, execute to the owner. That's me, which means that I can, in fact, read the directory name. I can read files in it. I can write to it. So if I create a file, if it's a file, I can destroy it. I can write over it. And if it's executable, I can execute it. And the next 3 bits, read, execute, means that anybody in my group, I'm the only one in the group, so, we can read and execute, but you can't destroy it. So if you belong to my department, say I'm in computer-aided design department, and we have an appropriate name for the group, and you get access to this file, you can read it and you can execute it because it's executable, but you can't modify it. So you can come into my sandbox and you can play with my toys, but you can't destroy them. And then other is anybody else in the system. Anybody in the system also has access to it. And if I want to turn that off, let's just show you the use of chmod. I can do chmod. Now you get to practice your binary to octal conversion. The first one is 111, so that's a 7. The second field, R-X, is a 5. And then the last one I just want to turn off. So I make it a 0. And I do run.sh. And it's changed. If I do an ls -l on run.shell, you can see that the last 3 bits are off. That's what the dash means in this field. So those 3 bits are off. That means that if they're not me, and if they're not in the group, they have no access to it at all. They won't see it. They won't be able to read or write to it. They can't write to it, and they can't execute it. So it gives me one more level of protection. Enough of that. I got to spend all day on each one of these, but okay. So we did chmod, compare. We'll come back to that. Copy. Did we do a CP? I think we did. CP is copy. It says copy file 1 to file 2. These got to be 2 different names. The first file is copied into the second, or okay, we'll stick with onto the semantics thing. It's going to create the second file if it doesn't exist. If it does exist, it will make an attempt to destroy it. So if you have write access to it, it will. If file 2 is a directory, then the target file is a file that's created in that directory. Let's do this. Let's do a backup. So what I can do, let's do a make directory backup. If I do an ls, you'll see that I've got a file here, a directory, because it's blue, it's a backup. So if I do copy run.sh to backup, because backup is a directory, it's going to go into that directory and create run.sh. Let's do the CD. We know how to do CD. CD to backup, do an ls, and I got run.sh, do an ls -l. And you can see it's the same as the run.sh in the previous, in the upward directory, the one above it. Let's go back. There was a CMP. I'll teach you that one. If you get one of these, just read it and see if you know if you can use it. CMP does a compare 2 files. 2 files are compared. You can also do standard to compare whatever. We're just gonna compare these 2 files, and if they differ, I can print to the byte number. That is, which byte starting with the first one differs from the file. So let's compare run.sh with run.sh in the above directory. Well, the above directory is project 01. There's a shortcut that says go to the directory above and compare this with run.sh. And they're both exactly the same. All right, compare. CP, date. We did the date before. Date, print and set the date. Here, it's Friday, August the 4th, 3 in the afternoon, Mountain Standard Time. If you are the root or super user, the date command allows you to go and change it on the system clock. You do not want to do that, okay, unless you're doing something nasty, okay. there's a thing called the network time protocol. All Linux systems should be connected to the internet because what they do is they use the network time protocol to verify your internal clock with the Universal Coordinated Time, the UTC, which is almost like GMT. It's supposed to be a match and stuff. There's a whole bunch there, but anyway, NTP, Network Time Protocol. How am I doing on time? 25 minutes and I haven't even looked. Whoa. All right, let's, DD, I call data dump, but they say convert and copy. Originally it was to copy a file in the input file into the output file, but if the output file is a device, then it's going to start at the first byte of the device and write the block. That's how you create file systems with a bootable image. Diff is kind of like compare, but we don't know it. DU, let's see, echo, exit was to use to exit a shell. That's to terminate a command file, or in this case, terminate our shell. File I talked about before, determine file type. So if I do a file star, I want to find out what kind of files each one of these are. My output files are all ASCII text. Backup is a directory. This is a C source program. A file tries to look at, if it's text, it will look at the, first 512 characters and try to determine what it is. It does not use the .c postfix to determine the type of the file. So if you got a .c or a .cc for C++ or a .f for Fortran, etc., it ignores that. Make files ASCII text. Primes is an executable. It's 64-bit, runs on an ARM AART64, which is what the Rock chip 3588 is. ELF means executable, loadable format. Just go to Wikipedia and look that up. Run shell is a born-again shell because the first line of run.sh has £, which is comment, but a comment with a bang says, what shell do you run? And that's that one, born-again shell. All right, enough. File. We're down to file, go to grep if kill. Well, I don't know if I did that. Login ls. List contents of a directory. And there are a whole bunch of flags and we've been using them. I've used it so many times. Look through the man pages here and see what all the flags are. Mail. Oh, we haven't done mail, but I guess I need to do that. Whatever, the man pages. Run off section of Unix manual. So man would reproduce this page. The original founders of Unix, they had to beg, borrow, and steal equipment. They found an unused PDP-7. They used it to start creating Unix. They found unwanted teletype model 33 ASRs, automatic send and receive. Dumb terminals later on at typewriters stuff. Make directory. Make a directory. Move is to rename or move a file. So if you've got a file that you want to rename, this is the way you do it. And if the name is a directory, then name one is moved to that directory with its original file name. Password, this is how we set our password, but it's shown password, name, password. That's the, this can only be done by corresponding user, but later we added password is allowed with no arguments by a simple user. So I can change my password to something new. Recommendation is you do this periodically, but I've been using the same password since 1972. I won't forget it. PS, process status. Let's see what I'm executing from this shell. Do a PS, and I'm running the simple screen recorder in the background. It's been running 43 minutes. My overtime, 31 of it, I've been actually doing something. If I do a PS, this says list everything that's executing in the system by me. And you can see I've got a whole bunch. I mentioned the 4 copies of Prime are running, and they've been running for more than 36 minutes. And it also gives me the arguments. So I know that the output from this file is going to o21.out. It does not show you redirection. Nobody thought it was needed. PWD, print working directory name. So this shows you where you are in the file system from root. PWD shows me you go to the top directory, which is the root directory. Then there's a directory home, and then in home, let's go cd/. You do an ls, and this shows you all the starting directories and paths to the rest of the file system. Lib and sbin are links, and then temp has all the bits on. That means everybody can create a file in temp, and we'll do that somewhere. Now if I cd to home, and I can do that because it's allowed for all users, I can find out there's me and there's Orange Pie. Well, let's sneak into Orange Pie's directory. Let's go into his sandbox, or hers. Permission denied, because I don't have the right. I can't even list it to see what the permissions are. I just don't have access, which is good. If I do cd, change directory, without any name, it goes back to my home directory. So you can be thousands of miles away from home and do a PWD, and it'd be like Dorothy and the Wizard of Oz. There's no place like home. RM for remove, or to unlink files. And so, now this is important. RM removes the entries for one or more files, so you can remove a bunch of files at once. If the file is being used by somebody else, it has another link to it, it will not be deleted. It's just where you are, that file name is removed from the directory. If you're the last person to access a file and you remove it, it's gone. Removal of a file requires write permission, okay, in the directory where the file is, but neither read nor write permission on the file itself, okay? So if you have no write permission, then You can't delete it. If you delete it, it's gone. There's some option here. -F says even if it's, okay, if it's read only, it will not delete it. But if you do a -F, it says force the deletion of the file. And you had better be, you better know what you're doing if you use it in that mode. Remove directory, that's easy. Shell, one of the things that this was done before, I don't know what year System 6 came out, but evidently Bash, surely that's not, is that, nope, that's basic. Oh, look, we got basic. Where was it? Shell. That's a regular bourne shell. Shift size sleep. I did sleep in a deal. Spell split strip. Strip does the following. It removes a symbol table and relocation bits. Okay, from the output of the compiler. Okay. It's useful to save space. We'll see how much later. Strip time, we know how to do that. Time a command, okay? Now this is old. Elapsed time is accurate to the second. The new version of time is accurate to a millisecond, and it's probably even better than that, but there's probably not much use. Let's look at the new man page. Man time. No entry. Okay. Some kids stripped it out. Wait. We know about wait. WC word count. Okay, counts the lines and words in the name file. Word is a maximal string of printed characters delimited by spaces or tabs or new lines. There's a new improved version, which is going to give us the number of lines, number of words, and number of characters. And that's it. Now we've covered some more lines. Let's go look at Linux man pages online. Okay. Man 7. Okay, the links from just HTML. Let's see what this gives us. Individual sections. Let's go to section 1. This is everything that's in the new Linux, in the new man pages. Let's see, let's see if there's a G, we use some, let's see if they are listed here. I'm looking for, excuse me, sorry. FG, HG disk. Remember we did, nope, it's not listed here, so it's in like G disk. GCC is our GNU Project C and C++ compiler. It shows you all the options. Let's look, I talked about there's a whole bunch of options. I was looking for the optimization flag to see what values were applied. You can compile executables for other processors. It's called cross compilation. For instance, if I were still doing 68,000, or does it do 6,800? Nope, just 68,000 processors. I can compile an executable. Say you've got a 68,000 embedded in something and you don't have a compiler or operating system for it. I can create a new binary firmware and load it into the system. There's stuff here for, I'm pretty sure there is stuff for MIPS and HP. Okay, let's see if I got, it does Fortran and other things. Let's see, -O, How about a capital O? Must be further down. No, they're not in ANSI standard. Okay. Oh, there's these standards. There's a C90, C89, and a C99 standard. Sometime this year, there's going to be a C23, the new version that supersedes the ISO ANSI standard, which you're using the Kernahan book out of. By the way, I talked to Brian a couple of days ago to find out if he had a copy of all 8 manuals, and he does not. So the race is on to find those. Let me see. I'm looking for the O. Let's see. Sorry to take up time, but it's important. I want to do this. It's my universe. Wow. Did you see? This is just, it'd be best just to read the book. I'll come back. So how many of these do you think tail? Did we see tail in the other one? We didn't. Tail. Output the last part of a file. Print the last 10 lines. And with a -L option, where is it? -NL. Print minus, where is, there's a way, -N followed by a number, or minus lines equal a number, output the last lines. There's a, for tail, there's a head. This will kill you. This will take your time. This will eat you. This will be a rabbit hole unbounded. Output the first part of the file, output the first 10 lines, do a -N, and get more. Someday we will get through a bunch of these. And I've eaten up more than 30 minutes, and I apologize. 42 minutes. I don't know what my record is so far, but I promised you we would go through some of the commands. We didn't get them all because they're not all listed in the first manual, and there's a lot more to go. So stay tuned. I'm standing by. Oh, and thanks to the individual that sent me a personal message via my YouTube account, Chuck Adams. And if there's something you want me to cover, you can ask, and I may or may not get to it. I'll try if it's apropos to what we're going to do. Thank you for your time. Convert this to MP4 for YouTube and post it.